Hello everybody, welcome to today's lecture number 4. Today also we'll solve one problem related to the variable mass concept, and this problem will include one cart which is full of sand, and through a hole at the bottom of the cart sand is falling down. So let's look at the problem. A cart loaded with sand moves along horizontal floor due to constant force F acting in the direction of the cart's velocity vector. So force is acting in this direction and the velocity of the cart is also in this direction. And sand spills through a hole at the bottom at a rate of mu kg per second. So one hole is there, through it sand is falling down, sand is spilling out. And at t equal to 0 the cart velocity is 0 and mass is m0. Find out the acceleration and the velocity of the cart as a function of time. See, this cart, constant force is being applied in the right direction. If we call it positive x-axis, so F is being applied continuously in the cart, but through the hole sand is spilling out. So that means what? That means this mass of the cart is not constant. So at any point of time, the mass m, if we tell that it is a function of time, because if we start from t equal to 0, the mass is m0, and after some time some sand has already gone from the system. So it is a problem of variable mass. Force is being applied in the right direction and the mass of the cart is not constant because the sand is continuously falling out. So see, the mass at t equal to 0, the mass is m0. So at any point of time the mass will be the mass initial minus the mass which has already left the system. So see, at time t, how much mass will be going out from the system? If the mass is losing at a rate of mu kg per second, so in t time the mass will be lost is mu into t. So mass that will be lost is mu into t. So at any point of time the mass will be m0 minus that mass is already lost, that is mu into t. Now see, mass is continuously decreasing but the amount of force is always constant. So if force is constant but the mass is decreasing, that means the acceleration will rise. With time the acceleration will rise because the force is constant, mass is continuously decreasing, so the acceleration will be rising. So at any point of time the acceleration, this is also a variable quantity because force is constant but mass, that is not constant because the mass is decreasing with time. So the acceleration will be increasing. So at any point of time, what will be the value of the mass? m0 minus the mass it has already lost, that is mu into t. So that is the acceleration of the cart with respect to time. This is the function of the acceleration. Now if I have to find out the velocity of the cart at any point of time, see this acceleration is varying. So at any point of time the acceleration is a rate of change of velocity, dv dt we can write m0 minus mu into t. And the sand that is spilling out, that is not giving rise to any thrust force because the sand is falling downward and that is falling also with relative velocity 0 with respect to the cart. So the sand is not creating any thrust force either left direction or right direction because it is falling downward directly and it is falling with relative velocity 0. So as v are equal to 0, the thrust force generated due to the sand spilling out is 0. Because no sand is forcefully being thrown out from the system, rather the sand is just falling down just by its own mass, it is falling down. Okay. So at any point of time, what I was discussing that, but at any point of time the velocity dv dt, at any point of time dv dt is equal to f by m0 minus mu t. Now see, with time, as I told that acceleration is not constant, rather it is increasing with time because the mass is decreasing from the system, mass is losing. So dv dt, that is f by m0 minus mu. You can write dv is equal to f dt by m0 minus mu t. So we can integrate this. The initial velocity is 0. At any point of time the velocity is v, and time initially it is 0. At any point of time I have to find out. So we can perform this integration. So see, if you perform this from 0 to v dv, integration of dv, and this integration is log of the denominator m naught minus mu t by minus mu, and the limit will I'll put from 0 to t. Now f by mu I'll keep minus f by mu I'll keep minus 1 into ln of m naught minus mu t minus ln of m naught minus ln of m naught. So it can be written as f by mu ln of m naught by m naught minus mu into t. This is the velocity at any point of time. Okay, so both the answers I have got, that is the acceleration as a function of time as well as the velocity as a function of time. So this is the acceleration as a function of time and this is the velocity as a function of time. I hope you understood. Thank you so much for watching.